Video lesson 9.5. Here we're going to solve more log problems, some more advanced ones, along with some exponents that we're going to use logs in order to solve them. So let's look at example number 1. In this case here, I do have logs on both sides, but I do have multiple logs going on within one side of the equation. So just like we did in the past, we want to at least condense this and trying to eliminate this as much as possible. So in this first example here, let's condense this expression. So I've got 3 plus, that would be log base 2, I can multiply them, of 3x is equal to log base 2 of 96. Now if it was just the logs, if I eliminate this 3 for a second, then I could just drop the logs and set the expressions equal to each other. But because of the 3, I can't do that. So in order to drop that, I have to have 2 logs equal to each other in order for that process to happen. So in this case, we got to get everybody to one side, right? And set it equal to a constant so we can condense them more. So I'm going to move this over. So I'm going to subtract this log base 2 of 96 over to the left side. I'm also going to take the 3 and move it to the right side. So that would give us, let's be log base 2 of 3x minus log base 2 of 96, which would equal, and if I also, again, if I was to like minus the 3 over and minus the log base 2 of 96 over, that's what we're doing here. All right, that's going to give me a negative 3 on this side. So now I can condense this again, because again, like bases. So log base 2 of 3x over 96, using that quotient rule, equals negative 3. Once I'm in this form, now I could whale it like we did in the past. So I can under over. All right, so that's going to give me, I'm going to write it up here. That's going to be 2 to the negative 3 is equal to 3x over 96. This is the same thing as 1/8, because that's negative exponent means it drops into the bottom. So it's going to be 3x over 96. Cross multiply, 24x is equal to 96. X is going to equal 4 when you divide that by 24. All right, so that's the process. Again, I always like to go back, check my answer, plug it in, see if it works. All right, example number 2, similar concept. I'm going to try and condense this as much as possible because, again, I got multiple logs on one side. So this multiplier, I can rewrite that as an exponent. And then I'm adding, right? So that means I'd be multiplying these two things. So reality is I'm going to have 27 raised to the 1/3. And then I'm going to multiply that by the 6th part. So let's do that in 2 steps, though. So that'll be log 27 raised to 1/3, right? Equals all of this. That's power over root. So first power over 3rd root. So the 3rd root of 27 is just 3. So that's going to be log of 3 plus log of 6 equals log of x. I can condense this to just be log of, multiply those together, is 18 is equal to log of x. So here, since I have a log equal to a log, this is where I can drop the logs and just set the expressions equal to each other. So that makes x is going to equal 18. And then you're done. Once again, go back, check your answer, plug them in if you have time, and utilize the calculator to see. All right, next examples. Number 3. Now, I won't lie, number 3 is going to be a bit lengthy here, but let's see if we can work through this as best we possibly can here. So, in examples like these, right, I want to actually utilize the logs to break this down or simplify it. So, in this case, I'm trying to take it out of this exponential equation form, make it into a log form, and allow me to use my log rules to try and solve this one. But based on how this one's looking, looks like this is going to be a little lengthy. Let's see. So I can't simplify anything here with this weird exponent here. I can't really do much. So best thing I can do is take the log. Now if I take the log of both sides, I gotta keep it balanced. So I can take the log of this side and I take the log of this side. So all of this and all of that. Okay, when I do that, once I do that, I notice I got the exponent. I can power that down, put it in the front. So that's going to give me log, this exponent, log x plus 1, right? And then I'm left with times log of x plus 1 equals log of all of this. All right, so let's do some simplifying here. So I've got two of this exact same logs and I'm multiplying. So I can just square that. So I can say that's log squared of x plus 1, right? Again, I have two identical terms being multiplied, so I can just rewrite that as just a squared term. So we like to put the little exponent over the log part, make it easy to see. Now here, it's already condensed, but this is not nice to play with. So if I actually expand this, I can simplify this a little bit. So if I rewrote this, because this is just multiplication, so that's the same thing as log 100 plus log of x plus 1, right? And the reason I'm doing that is because this comes out to be a nice whole number. Now, if it wasn't a whole number, I wouldn't have done that. But because it's a whole number, I'm going to do that. So let's keep this here, right? Equals log base 10 of 100, right? That's going to be 2, again, aka 10 raised to what power would give me the 100 is what I'm looking for. So that's going to be 2 plus log of x plus 1. Now, again, just like we had in the past, I can move these over and try to do it. But when I move these over, right, if I move this log over, I have a log squared, right, equal minus this log here. I don't have things like I did in the past where I can actually use my rules because I got different exponents going on. So I'm going to move everybody over. So I'm going to make this log squared of x plus 1 minus log of x plus 1. I'm also going to move the 2 over and get everybody equal to 0. And this is why. And it's hard to see at first glance, but I think you'll notice a little bit here. I'm going to make a let statement. So let a equal the log of x plus 1. Because notice I've got x plus 1 here and x plus 1 here. So if I rewrote that, that would be a squared minus a minus 2 all equals 0. And that's something I could factor, right? I could factor that. I can say that in this expression, that's the same thing as just, what is that, a minus 2 and a plus 1. Well, it's not really a's, right? I could solve that. A would be 2, a would be negative 1, but it's not really a's. It's really log of x plus 1 is equal to those, right? So now, let's do this over here. I can rewrite them. So first one's going to be log of x plus 1 is equal to 2. Again, under over, we'll whale it. I've got 10 to the second is equal to x plus 1. So that's 100 equals x plus 1. So x would be 99. Or the log of x plus 1 could equal negative 1 because we have the a is negative 1 also. So again, whale it. So I've got 10 to the negative 1 is equal to x plus 1. That's the same thing as 1 over 10 is equal to x plus 1. If I subtract the 1, I'm going to get 1/10 minus 1, or 10/10. So that's going to be x is equal to negative 9/10. All right. Once again, always go back, check your answers, especially the negative numbers. You want to make sure you don't get any negative values that you're trying to take the log of, because that's not going to work. All right, but this one definitely more involved, more complex of a concept. This is that little trick here that we've done in the past with other things, kind of rewriting the expression. We did it with trig equations as well. So we utilize that little trick to kind of make this a simpler factoring problem. All right, and then be able to solve it from there. All right, let's look at another one. Example number 4. Let's see. All right, so in this case here, at this stage, I got nothing to do here. I can't solve this anyway right now. I can't use any of my exponent rules or shortcuts for trying to solve an exponent equation. So if I rewrite this in the log form, I could then start manipulating it. So I can take the log of both sides. So if I do that, log of both sides, I'm going to get log of 5 x plus 2 is equal to log of 9. Again, when I do this, I can take this exponent, I can power it down. So I can have it as x plus 2 log of 5 equals log of 9. Again, remember this is multiplication. So if I'm trying to solve for x, I could divide out the log by 5. Log of 5. All right, so I'm going to have x plus 2 is equal to. Now, this expression is not a nice number, so leave it like that. Leave it as log of 9 divided by log of 5. All right, then we can go back into a calculator on if we need to. So next step is to minus the 2 from both sides. So I'm going to be left with x is equal to log of 9 over log of 5, all minus 2. Again, if it doesn't tell you to round, you could leave it in that format. For argument's sake here, I'm going to say let's plug this into the calculator and just get me a rough decimal estimate here. So let's just take our calculator real quick. I'm going to type that in. So we got log of 9 divided by log of 5. And then I'm going to subtract that entire answer by 2. So I got x to equal approximately, I'm going to round it here, to negative 0.6348. All right. Again, I want to check that, make sure it's not going to cause me any problems. In this case, it doesn't, so that's my answer. So different type of question, but perfectly fine. Nothing wrong with getting a decimal answer. A lot of times we do. Just got to be extra careful. All right, and last but not least, example number 5. Definitely looking ugly. All right, so hopefully we can try and clean this up a little bit, make things easier. So first thing I notice is I got same logs on the same side of the equal sign. So I'm trying to condense this. So I'm going to take the multiplier, make it an exponent. So I got log of base 2 of all of this squared plus log base 2 of all of this is equal to 1. I can condense this. So I'm adding them so I can multiply those. So I've got x minus 7 over x minus 1 all squared times x minus 1 over x plus 1 all equals 1 of this log base 2. Right? At this point, I can whale it because this is all one expression, right? So I'm going to take this and I'm going to whale it. So on top comes out. So I'm really going to be left with this crazy thing, x minus 7 over x minus 1 squared times x minus 1 over x plus 1 all equals 2 to the first, which is just 2. To make this nicer, right, let's kind of expand this out, because if I'm squaring this fraction, I'm really squaring the top and the bottom. So I'm going to, let's do this over here. I'm going to say x minus 7 times x minus 7 over x minus 1 times x minus 1 over x plus 1 all equals 2. Okay. So let's make this simpler. I can simplify here. I'm going to numerator and denominator with the same expression. And now I can just multiply them. This is going to get me x squared minus 14x plus 49 over Well, that's just dots, right? So that means that that's going to be x squared minus 1, all equals 2. So I put this over 1, I can cross multiply. That'll give me this part here. So let's do this and this. So that's going to get me 2x squared minus 2 equals x squared minus 14x plus 49. Only thing I can do here is get everybody to one side, right? So that's going to be subtract everybody over from the right side and make it to the left. So it's going to be x squared plus 14x, and that's going to be minus 51, all equals 0. That's something that I can factor. Let's see if I can squeeze it in over here. So if I factor that, right, let's see, we're going to get 51, that would be what, 17? Yeah, 17 and 3. So one's positive, one's negative. So I got this is going to be x is equal to negative 17. X is going to be equal to 3. Once again, I'm going to go back, check these don't make my logs values a negative number. They don't, so those are my answers. All right. Again, another complex one, but something that is very plausible and something that you guys should be able to do in the grand scheme of things. Again, it takes a bit of practice and a bit of look, so take a chance, watch the video. Again, if you have to rewind and go over any of this, please do so, and then utilize the practice problems for better understanding.